Today we are going to evaluate Serret's integral, which is the integral between 0 and 1 of ln 1 plus x upon 1 plus x squared dx, and we are going to show that that equals pi by 8 ln 2. And the method to be used is substitution, and so we let tan u equal x, which means that sec squared u du equals dx, so that tan squared u plus 1 du equals dx. And changing the limits, the integral between 0 and 1 becomes the integral between 0 and pi by 4 of ln 1 plus tan u over 1 plus tan squared u times 1 plus tan squared u du. And so our integral is the integral between 0 and pi by 4 of ln 1 plus tan u du. And by the King's property, the integral is the integral of pi by 4 plus 0 minus x, which is the integral of pi by 4 minus x. And so we have the integral between 0 and pi by 4 of ln 1 plus tan pi by 4 minus u. And by the trigonometric identity, the tangent of pi by 4 minus u is tan pi by 4 minus tan u over 1 plus tan pi by 4 tan u. And so by the trigonometric identity, tan pi by 4 minus u is tan pi by 4 minus tan u over 1 plus tan pi by 4 tan u. And tan pi by 4 is equal to 1, and we recall that the integral we're evaluating is the integral between 0 and pi by 4 of ln 1 plus tan u, except that u is replaced by pi by 4 minus u. And so we can see that the integral we want is the integral between 0 and pi by 4 of ln 1 plus 1 minus tan u over 1 plus tan u. That is, bearing in mind that tan pi by 4 equals 1. And so if you replace 1 by 1 plus tan u over 1 plus tan u, which is what I'm doing in the bottom left-hand corner of my slide, at the top I've got 1 plus tan u plus 1 minus tan u. On the bottom I've got 1 plus tan u, and therefore our integral is the integral between 0 and pi by 4 of ln 2 over 1 plus tan u. And so the logarithm between 0 and pi by 4 of ln 1 plus tan x is equal to the integral between 0 and pi by 4 of ln 2 over 1 plus tan x, where I've just swapped the u's for x's. And so the integral we want, which is the integral between 0 and pi by 4 of ln 1 plus tan u, is the integral between 0 and 1 pi by 4 of ln u 2 minus the integral between 0 and pi by 4 of ln 1 plus tan u. And if we use I to represent the integral we want, which is the integral between 0 and pi by 4 of ln 1 plus tan u, that amounts to saying that I is equal to the integral between 0 and pi by 4 of ln 2 minus I, which shows us that 2I is the integral between 0 and pi by 4 of ln 2 dx. And applying the integration rule, that is the x ln 2x taken between the limits of pi by 4 and 0, which is pi by 4 ln 2 minus 0, which is pi by 4 ln 2. So we can now see that 2i is pi by 4 ln 2, and dividing both sides by 2, we have I equals pi by 8 ln 2, which is what we're aiming to establish. And so I now think we have earned ourselves a cup of hot chocolate.